Good morning. Escape velocity is general form. We have discussed the escape velocity as the minimum velocity with which a body is to be projected so that it can escape from the gravitational field of Earth. So far we have discussed in the one-dimensional motion, that is the particle is projected in vertically upward direction. Now we can look at if the particle is projected at an angle alpha with the vertical. This time we are projecting at an angle alpha. The force on the mass m is, we know according to Newton's law of gravitational, F is equal to minus gmm by r square into r. The particle is projected to a distance r. Capital M is the mass of Earth, small m is the mass of the particle which is to be projected, g is the gravitational constant. But using the relation my gmm by r square is equal to minus mg, we can substitute for gmm. This value of gmm is equal to mg into capital R square. This is substituted here. Then F becomes F is equal to minus mg into capital R square by R square, small r square, the unit vector R. And to use the work energy theorem, we have to calculate work, that is F dot dr, that is path to be known. But we are not sure about the trajectory or path of the particle. So we are assuming a small elemental path, and in polar coordinates it is given as dr is equal to r dr plus theta r d theta. This r and theta are unit vectors in polar coordinates, and applying the F dot dr, we are taking the dot product minus mg r square by small r square this r dot r, unit vector r dot r is equal to 1, but r dot theta is 0. Only the first term will exist. Therefore we get, using the work energy theorem, half mv0 square, v square minus half mv0 square is equal to minus mg r square integral capital R to small r. Capital R is the radius of Earth. The particle is projecting from the surface of Earth. That is, at the surface of Earth, value is capital R, where v is the velocity at a distance small r. It is half mv square minus half mv0 square is equal to minus mg r square into 1 by r square. Integral 1 by r square is minus 1 by r within the limits capital R to small r. By applying the limits mg r square into 1 by r minus 1 by capital R. When r is equal to infinity, the particle is escaping from the surface of Earth. Then we are considering r to be at infinity, and the initial velocity becomes the escape velocity, that is the minimum velocity with which a particle is to be projected so that it can escape from the surface of Earth, gravitational force of Earth. And the final velocity is assumed to be 0. Substituting these three values in this equation, we get half mv square is equal to minus mgr, v is equal to root 2 gr. We got the same result as we got in the earlier case when we are projecting it vertically upwards. Now in this case we projected at an angle alpha, and it is sure that the velocity is independent of angle of projection. It is proved. Okay, thank you.